Today's topic is non-destructive test methods. So non-destructive test method, it is a method of testing existing concrete structure to assess the strength and durability of the concrete structure. So in a non-destructive test, without loading the specimen to failure, we can measure the strength of the concrete, especially the compressive strength. So this method of testing also helps us to investigate crack depth, micro cracks, and deterioration of the concrete. So what is the purpose of doing this non-destructive test? So mainly, firstly, that is we can identify the areas of lower integrity. We can detect the presence of imperfection. We can measure the elastic modulus. Also, we can estimate the that is compressive strength, uniformity, quality, and homogeneity. So, following are the different methods of non-destructive test on concrete. First one, penetration test. Second one, a rebound hammer method or rebound hammer test. Pull-out test method. Ultrasonic pulse velocity method. Radioactive method. Core extraction test. These are some of the tests conducted on NDT, that is a non-destructive test. Firstly, it is a penetration test. So this penetration test is used to determine the strength characteristics of the concrete. This is done by driving a probes into the concrete sample using uniform force. So commonly used penetration resistance method is Windsor probe system. See, this Windsor probe system is generally considered to be the best means of testing penetration. So this equipment consists of powder actuated gun or a driver, hardened alloy probes, loaded cartridges, a depth gauge for measuring penetration of the probes, and other related equipments. You can see here. Okay, this is an equipment. It consists of It consists of an powdered actuated gun or a driver, hardened alloy probes, and loaded cartridges. And this diameter of the probe is 6.5 mm and length is 8 centimeter. So it is driven into the concrete by means of a precision powder edge. You can see here it is driven into the concrete. Okay, and this depth of penetration provides an indication of the compressive strength of the concrete. See, although calibration charts are provided by the manufacturer, the instrument should be calibrated for type of the concrete and type and size of the aggregate used. So what are the benefits of this test and also some limitation of this test? So it has however, the potential for providing a quick means of checking quality and maturity of the in situ concrete. The test is essentially non-destructive since concrete and structural members can be tested in situ with only minor patching of holes on exposed faces. The test procedure is it will give quite variable results and it should not be expected to give accurate results of concrete strength. This is the limitation of this method, that is a penetration method. Next method is a rebound hammer method or a rebound hammer test. So it was invented by Ernst Schmidt in 1948, a Swiss engineer. So it is commonly known as Schmidt rebound hammer. This surface hardness method consists of impacting the concrete in a standard manner, activating a mass by giving energy, and measuring the indentation. So the most common and widely used instrument is a rebound hammer. There are several types of hammer having this impact energy varying from 0.7 to 3 kg meter. This a Smith hammer, it is also known as Swiss hammer, rebound hammer, or a concrete hammer. So this is a rebound hammer. You can observe here. This is the apparatus rebound hammer, and this is the concrete surface. So this rebound hammer, you can observe here. You can place your rebound hammer in the horizontal position, okay, or you can place the rebound hammer in the vertical position also. So this is the surface. You can place horizontally or vertically downward position or vertically upward positions or any inclined position. Okay, the procedure is like this. How to conduct this test? So this rebound hammer, it normally consists of a spring control hammer that slides on a plunger within a tubular housing. Okay, it consists of a spring control hammer within a tubular housing. This is an housing. You can observe here. It is a tubular housing. When the plunger is pressed against the surface of the concrete, the mass rebounds from the plunger. It retracts against the force of the spring. The hammer impacts against the concrete and the spring control mass rebounds, taking the rider with it along a guide scale. By pushing a button, the rider can be held in position to allow the reading to be taken. The distance traveled by that mass is known as rebound number. It is indicated by the rider moving along a graduated scale. So you can observe here, this is a rider on the guide scale. So where it indicates the rebound number. This test, as I said, this test can be conducted horizontally or vertically, upwards, onwards or inwards, or at any intermediate angle. A minimum of 10 readings is compared, and each reading it should not differ by more than 7 units. The average of remaining reading determined for evaluating the strength. If more than 2 readings differ from average by 7 units, the new set of readings it should be taken. So we will get the rebound numbers. So if the average rebound number is greater than 40, then we will say that the quality of the concrete is very good. That means it is in hard layer. So if the rebound number, if it is in between, so what we will get the rebound number, if it is in between 30 to 40, it is a good layer. Rebound number, if it is between 20 to 30, it is a poor concrete. If it is rebound number is less than 20, then it is a very poor concrete. So these are some of the advantages and limitations of this test, rebound hammer test. The Smith hammer, it provides an inexpensive, simple and quick method of obtaining an indication of concrete strength. So these results are affected by the factors such as smoothness of the surface, size and shape of the specimen, moisture condition of the concrete, type of the cement and coarse aggregate, extent of carbonation of the surface. Thank you. For better understanding and visualization, you can watch the following videos. Thank you.
Penetration tests on concrete. Penetration resistance methods are aggressive NDT procedures that are used to determine the strength properties of concrete. This method is done by driving probes into concrete samples using a uniform force. The most commonly used penetration resistance method is the Windsor probe system. The system consists of a powder-actuated gun, which is used to drive hardened alloy steel probes into concrete structures and measuring unit. A probe of diameter 6.5 mm and length 8 cm is used for testing. The gun is placed on the required location and probe is forced onto the concrete sample. The depth of penetration of the probe provides the indication of the compressive strength of the concrete. The depth of penetration is generally correlated with the compressive strength of concrete. The main disadvantage of this method is it makes a hole and damages the structure, and the accuracy of the result is quite low compared to other testing methods. Thank you for watching. Stay tuned. The best is yet to come. Kindly do like, share, comment your views, and finally don't forget to subscribe our channel. Surface hardness methods. Non-destructive surface hardness methods are non-invasive procedures that investigate strength characteristics of the concrete structure. This is generally done in any of two methods, such as indentation methods and rebound methods. The rebound method is frequently applied to investigate concrete strength characteristics of concrete. This test was developed in the year 1948 by Swiss engineer Ernst Schmidt, and thus it is commonly referred as the Schmidt rebound hammer. The rebound hammer is a spring control hammer that slides on a plunger within a tubular housing. The entire setup with their label is shown on the screen. When the plunger is pressed against the surface of the concrete, the mass rebounds from the plunger. It retracts against the force of the spring. The hammer impacts against the concrete and the spring control mass rebounds, taking the rider with it along the guide scale. The rider indicates the distance traveled by the mass, which is called the rebound number. The typical relationship between compressive strength and rebound number with hammer horizontal and vertical on a dry or wet surface of the concrete is shown on the screen. The value of rebound number is taken an average of 15 reading. The table shown on the screen shows the average rebound number and quality of concrete. There are many types of rebound hammer which varies considerably in performance, types of, and needs calibration for use on different types of concrete. This test can be conducted horizontally, vertically, or at an inclined angle. Thank you for watching. Stay tuned. The best is yet to come. Kindly do like, share, comment your views, and finally don't forget to subscribe our channel.